This is example 5 of section 3.7. What I would like you to do is press pause to the video and see if you can solve the entire problem, and then unpause it to check your work. So here we go with the solution. I'm first going to find the derivative with respect to x of the entire relationship. Tangent of xy plus x squared y plus 2 equals x. Notice this is the tangent of stuff, and within the stuff we have to do a product rule. So here we go. The derivative, tangent stuff, is secant squared stuff. Now we're ready for the derivative of the stuff, and we have first term. And then the derivative of y with respect to x is dy dx. Remember, we treat y like it is its own stuff. Plus second term y times the derivative of x, which is 1. Plus, now we're going to do the derivative of this, also using a product rule. First term times the derivative of the second, plus second term times the derivative of the first, and then the derivative of 2 is 0, and then equals the derivative of x, which is 1. So this part, the derivative of this part, was all of this, and the derivative of this part was all of that. So now we're ready to do the algebra portion of this. If this entire problem 5 was worth 25 points, this line of information would have been worth 10. So a tricky step here is that this needs to be distributed to these two terms before we do anything else. So we have x times secant squared xy dy dx plus y times secant squared xy. Then we have plus the blue portion, x squared dy dx plus 2xy equals 1. So the goal is to isolate dy dx. So I'm going to factor dy dx out of x secant squared xy. See, this term has a dy dx in it, and this is the other term that has it. So plus x squared. And then I need to bring the other pieces to the other side via subtraction. So that's going to equal 1 minus 2xy minus y secant squared xy. Our last step here is to get dy dx by itself. So I am going to divide that entire quantity to both sides and show that here, divided by that. So that's dy dx. But the problem wants us to find an equation of the tangent to the curve at the point when y equals 0. So the next thing we have to do is figure out what the point is on the curve. I like to call this the amoeba because I don't know what it looks like. So I have to find a point on the amoeba when y equals 0. So if y equals 0, I'm going to substitute in the amoeba. So I have the tangent of 0 plus 0 plus 2 equals x. And the tangent of 0 is 0, so that is going to lead me to x equals 2. And the point then is 2, 0. Again, if this were a 25-point question, the light blue here analysis leading to the point 2, 0 would be worth 5 points. The algebra down here would also be worth 5 points. So the last 5 points then is finding the equation of the tangent line. So I need dy dx at the point 2, 0. So I'm going to plug that into my derivative, where 2 is for x and 0 is for y. And if you do all that, it comes out to be 1 minus 0 minus 0 over, let's see, 2 times 1 plus 4, so the slope comes out to be 1/6. And we're ready to write the equation of the tangent line. Y minus 0 equals 1/6 x minus 2. And there it is. That is the final answer to the question.